Yo, what's up all you low gangers and Jake Paulers? I've been on vacation at my friend's house in northwestern Idaho right now, and we've been, out fishing, swimming, performing seances at night, typical hot girl shit. And I've noticed that the forest around his house is a perfect example of primary succession or ecological succession. And you may ask, what is primary succession and ecological succession? And I'd say, shut the fuck up, I'm about to tell you. So anyway, cover your butts and buckle your belts, because this shit's important. Primary succession, also known as ecological succession, is the process by which desolate rock barrens, or any place desolate on this planet, could be sand dunes, volcanoes, rock barrens, whatever, turn into lush biomes such as this forest. It could be sand dunes turning into oak forest. It could be volcanoes turning into a jungle. Now, at least in this forest, the organisms which start off ecological succession are mosses and lichens. Now, you may not know what lichens are, which I'm not going to fault you for. I mean, not everybody goes into the wilderness. But I'm going to assume you're not an idiot and you know what a moss is. But for the sake of the runtime of this video, I'm going to explain both of them anyway. Now, lichens are a symbiote between two or more organisms. The first organism is always a fungus. And the second organism can either be a cyanobacteria or an algae. And I say or more because sometimes it's one or three funguses. We're not actually sure. For the longest time, scientists believed it was only one fungus, but recent studies have found that it might be more funguses. We don't know if the other funguses are a parasite of the original symbiote or what, but when scientists have tried to create lichens in the lab by putting fungus and algae together, it didn't create anything. And we believe that's because it needs other organisms as part of the symbiote. The fungus or fungi, in the case that there's more than one fungus, use the cyanobacteria or the algae to photosynthesize and give them food, whereas the cyanobacteria and the algae use the fungus as a structure and allows them to be in places where it's not wet. Typically, algae and cyanobacteria can only live in very moist, damp places, such as a pool of water, the ocean, a lake, whatever, maybe even a towel in some cases. Now, in some instances, there's cyanobacteria and algae, whereas others, there's only cyanobacteria or only algae. Lichens come in all shapes and sizes, such as this, and this. And there's many thousands of species. In America alone, there's 2,000 to 3,000. And across the world, who knows how many. Lichens are really important because alongside moss, they break down rock, creating soil and earth. Mosses and lichens together really do something incredible. They can break down rock by releasing acid, which digests the rock. Most plants, besides mosses, contain something called vascular tissue. Vascular tissue is the tissue inside a plant which transfers water and nutrients and oxygen throughout the plant. Think of capillary action. Now, mosses, since they're super simplistic plants, they were the first plants to reach land from the water, do not have this vascular tissue. Much of their leaves are a single cell thick. They don't really have any stems either. They're just a bunch of leaves that are single cell thick put together. Mosses and lichens together really do something incredible. They can break down rock by releasing acid, which digests the rock. And as I said before, this digestion creates earth and soil that other plants use to live and thrive on. As you can see here, if you pull off this dead moss, there's dirt under. This dirt was not here before. It was put there because the lichen and the moss digested the rock. If you pick up any moss or lichen in this forest, you'll see dirt under it. And this dirt wasn't there before the moss and the lichen. The lichen and the moss digested the rock and put it there. This is important because plants need earth and soil to survive. And then, when the moss and the lichen die, they decompose even more, creating even more soil in the earth. As you can see in this rock barren, this has been going on for a while. And that's why there's many plants like that bush and that tree, which are able to live here, even when there's no soil. Because for decades, the moss has been collecting, breaking down the rock, and decomposing, creating more and more dirt. This isn't enough to see the types of soil seen in this forest, but when other plants, such as bushes and trees, die, they decompose and create even more dirt on top of the rock. And that's how you get places like this where, you dig, you can see a rock exposed right here, but you dig an inch or two down anywhere in this forest and you'll find rock. This is important because ecological succession is some of the foundations of ecology. In the early 1890s, ecology was a booming new field. The term had only been coined in the 1890s by a German zoologist named Ernst Haeckel. Charles Darwin's On the Origin of Species and Charles Lyell's Principles of Geology really paved the way for the founder of ecological succession. And his name was Henry Chandler Coles, spelled C-O-W-L-E-S, but pronounced Coles. Coles was born in Kensington, Connecticut in 1869. Nice. And his mother from a young age would take him on walks down the road and teach him the names of flowers and trees. And then on his family farm, he would raise vegetables and flowers just for the fun of it. In 1893, he graduated from Oberlin College, where he had studied geology and botany. After which he then taught for a year at that very same college, and after that year he was offered a graduate fellowship at the University of Chicago. He started off studying geology, but later switched to botany. However, his interest in geology and his studies in geology influenced his theories on ecological succession and biology for the rest of his life. During his studies and during his career, he visited the Indiana Dunes many times to study the ecology. He also visited sand dune biomes all around America. No matter where in America he went, he found that these sand dunes would start off as empty beach with rolling sand dunes, which would then switch to beach grasses, and then to cottonwood, and then to pine tree, and then to oak forest. He found that these oak forests were something that he called climax succession, meaning that over time, these sand dunes all would turn into oak forest. It was the most stable biome and the most stable ecology for that area and that type of area, the sand dunes. He coined the term ecological succession, primary succession, secondary succession, and climax succession to describe this phenomena. Ecological succession is the overall term of an area's ecology changing over time. Climax succession is the term used to describe the most stable ecology of a specific area. And then primary succession is the term to describe the road to the very first climax succession. And secondary succession is what happens when, say, a wildfire or a flood comes through an area and levels everything to the ground. And then it restarts again to climax succession, but this time it starts off with dirt rather than sand or volcanic ash or rock barren. In the inland sand dune biome, such as the Indiana Dunes, the oak forest is the most stable ecology of that area, which is why overall across America, the sand dune biome keeps moving towards oak forest. The study of secondary succession is equally as important as studying primary succession, because when a wildfire comes through an area and levels everything to the ground, as what's been happening in the last couple of years, it's important for us to know what's going to grow after the wildfire. Many people believe that when natural disasters come through and level an ecosystem, it's purely negative, whereas many ecosystems need floods, wildfires, and hurricanes to level them from time to time. And that's part of the ecological succession that's been going on for millions and millions of years. It's important to that ecosystem, especially in California. We need controlled burns every couple years to wipe out all the shrubland. Getting rid of the undergrowth and the bushes allows more pine trees to pop up as the old growth forests die. A perfect example of this is redwoods and sequoias, both of which need wildfires for their pine cones to germinate. When the pine cones of the redwood and the sequoia fall to the ground, they just sit there. They can't germinate without wildfire. But when a wildfire comes through, the pine cones open up and the seeds can fall out, and baby sequoias and redwoods can germinate and grow into 2,000-year-old trees. Ecological succession is a very important field of study. There are many scientists who spend their entire lives studying one biome. There are people who devoted their entire lives to studying just the Indiana sand dune. We need to know what's going to happen to an ecosystem when a volcano comes through and kills everything and it's just barren rock, or a wildfire comes through and sure, there's a couple trees alive, but it's just ash for miles around. Anyways, I forgot to shoot the outro for this video. Apparently I didn't press the record button when I shot that up in Idaho. I only noticed that when I came for a quick little 10-mile ride to go through all the footage. But you'll notice scene change because I'm not in Idaho anymore. I'm up down in Long Beach, California, where I live. I'm trying to make a lot more and better content. I want to do my own experiments on this channel. And I intend to upload a lot more extreme sports and BMX videos. I ride BMX. For anybody that knows, I'm out doing 10-mile ride for my journey to training to ride all the way from Long Beach, California to Swamp Fest 2025 in Florida. I'm trying to do semi-weekly or bi-weekly posts on that on my TikTok, and I'm working to do daily posts. I'm trying to do on my TikTok at least, and then weekly posts on my YouTube. I would really appreciate a like, subscribe, and share. You can find me at Ecological on all platforms. Stay fresh, cheese bags.